Here we have a SAT math question. Okay, let's go with the information. The function f of x can be written in the form negative 2a x square positive bx positive 2c as a vertex at 1 comma 10 where a, b and c are positive integers. What is the largest possible value of b? Okay, here we have a function that is f of x equals to negative 2a x square positive bx positive 2c. Okay, here we have a quadratic function. Usually this f of x represents the y coordinate on xy plane. So we can change this f of x as y. So let me write it. So then the given quadratic function becomes y equals to negative 2a x square positive bx positive 2c. Now let's consider the quadratic function in the form y equals to ax square positive bx positive c. Whenever we have a quadratic function in this form, its graph will be a vertical parabola and the parabola may open up or may open down. So it depends on the value of the leading coefficient, that is a coefficient of x square, that is a. If a is positive, that is greater than 0, then the parabola opens up. If a is less than 0, then the parabola opens down. Okay, in our problem, the leading coefficient is negative 2a, which is a coefficient of x square. So now we have to decide. So the value of this leading coefficient, negative 2a, is negative or positive. For that, we have to consider the value of the constant a. So the question says a is a positive integer. Since a is a positive integer, when it is multiplied by the negative value, that is negative 2, so this is the whole stuff, this negative 2a is a negative value that is less than 0. Since the leading coefficient in our quadratic function is negative, so the vertical parabola we get for this quadratic function must open down. So here, let me sketch the graph of the parabola as open down. Okay, here for this parabola, we have the vertex 1 comma 10 that's given in the question itself. So here, when we consider the vertex of the parabola over here, the exponent of the vertex is 1. So let me write x equals to 1. Okay, so when we have a quadratic function in this form y equals to x square positive bx positive c, there is a formula to get the exponent of the vertex. So that is a negative b over 2a. So this b is the coefficient of x and the a over here is the coefficient of x square. Okay, let me finish writing this equation. Okay, in our problem, what is the coefficient of x? I mean, in our quadratic function, what is the coefficient of x? That is b. So here, even if I plug in the b for b over here, still I'm getting negative b. And what is the coefficient of x square in our quadratic function? That is negative 2a. So that we have to plug in for this a over here. Then I'm getting 2 times negative 2a equals to 1. Then we get negative b over 2 times negative 2a is negative 4a equals to 1. So this negative and negative will cancel out. So I am getting b over 4a equals to 1. Okay, now to get rid of the denominator 4a over here, I multiply both sides of the equation by 4a. When I do so, this 4a and 4a will cancel out. I am getting b equals to 1 times 4a is 4a. Okay, now I have solved for b in terms of a over here. So here, now what I need is I have to get the value for a. So because our aim is to get the largest possible value of b, so only if I get the value of a over here, I'll be able to get the largest possible value of b. So for that, what I'm going to do is I'm going to consider the vertex 1 comma 10. Actually, it is a point on the parabola. Since we have this point 1 comma 10 on the parabola, we can plug in this point into the given quadratic function over here. So that is, I have to plug in this exponent 1 for this x over here, and I have to plug in this y coordinate 10 for the y over here. Okay, let me do it. So then I'm getting, so here 10 equals to negative 2 a times 1 square positive b times 1 positive 2c. Then I'm getting 10 equals to, so the evaluation of this 1 square is 1 times negative 2a is just negative 2a, positive b times 1 is b, positive 2c. Okay, just now we got that b equals to 4a, so we can plug in this 4a for the b over here. Then I'm getting 10 equals to negative 2a, positive 4a, positive 2c. So 10 equals to, when I combine this negative 2a and positive 4a, I am getting 2a, positive 2c. So here this number 10 and the coefficient of a and the coefficient of c. So all of them have the greatest common divisor 2. So better we can divide each term of this equation by 2 to make the number smaller. So let me divide this one by 2, this one by 2, this one by 2. So when I divide 10 by 2, I'm getting 5, and here this 2 will cancel, here 2 will cancel. So I'm getting a positive c. So here I'm getting the value for a positive c, that is 5. So the question says a, b, c, all of them are positive integers. So now we have to get some values for this constant a and c. so that the addition of this A and C equals to 5. So how do you have to get the values for A and C? Let me write the stuff over here. So here A and C. Since A and C both of them are positive integers, first let me take the first positive integer, that is 1 for A. If A equals to 1, then C must be 4. So that when I plug in A equals to 1 and C equals to 4, the result of A positive C must be equal to 5. Or I may take A equals to 2. So if I take A equals to 2, then C must be 3. So that A positive C equals to 5. Or I may take A equals to 3. Then C will be 2. Or I may take A equals to 4, then C will be 1. So I cannot take A equals to 5, because if I take A equals to 5, then C will be 0. C is equal to 0 means that does not satisfy the condition given out here, because C also is a positive integer. So like here we have 4 pairs of values for A and C. Now actually we have solved for B in terms of A over here, and our aim is to get the largest possible value of B. Since our aim is to get the largest possible value of B, we have to consider the largest possible value of A over here. So the largest possible value of A is 4. So then we have to plug in that 4 for A over here. Then we get 4 times 4. Then we get B equals to 16. So the largest possible value of B is 16.